Great. So, hi, I'm Piotr. I'm a Python developer, and I will be presenting for you what are the JSON Web Tokens, why they don't bite, or if they can bite or not. So let's start. This is JSON Web Token. I don't know how much of you know what it is. And can it bite? Of course it can. It has teeth. Okay, thanks. That was all today. Any questions? Okay, let's get real. So this is a JSON Web Token again. It contains three parts. First one is header. This is just the description how to read this particular JSON Web Token, if it's encrypted or only signed, because JSON Web Tokens can also be encrypted, and what algorithm was used to either encryption signing it. The next one is the payload, so the actual data that we want to contain inside the token. As you can see, this is just some random data with something random, yeah. And the signature that is like, well, the signature, it is cryptographically computed based on the algorithm you have, you specified, etc. And it's just verifies, you can just verify if the header and payload is like comes from the trusted party. It is not like created by user by himself or somebody else, etc. So if the signature is valid with the provided key and those parts, it is created by somebody that knew the key. So what is this used for? Authorization and information exchange. So if we, for example, logged in the user and we want to give him access to the service that we provide, we create for him the JSON Web Token, and each and every request, if it's HTTP API or something else, with each request he should send this JSON Web Token, that, for example, this one, and if this JSON Web Token is valid, we can trust that this is this user that is described with this payload. It can also be used for any information exchange. So if we want to send somebody some information which is not secret, or if it's secret, we can use the encrypted version of JSON Web Tokens. And he can trust that this data is from us, it wasn't prepared by somebody else, it can be published somewhere, etc. So, payload, so the second part, can contain some data. They are called claims. We have some registered claims that are specified in the specification. They are always 3 letters long, and we can say encrypt. We can provide in them what is the expiration date, what's the issuer, who is the subject for this JSON Web Token, etc., etc. They are also the public claims, so something that is used for some public API or public data. If we want to specify some public API that uses JSON Web Tokens, all the claims that we are using should be published somewhere, so everybody may read it and know what they mean. And for private use, we have just some private things. We can store it, store anything we want actually inside. So signature algorithms, and for just some clarification, I won't touch the encrypted JSON Web Tokens today, because I think that they are pointless. We can just encrypt the data and put in signed inside the claims of the signed JSON Web Tokens. So that won't be the case today. So those are some signature algorithms that you can use that are specified in the RFC for the JSON Web Tokens. And we can go to JSON Web Tokens in web authentication because that data exchange, like, it's self-explanatory, and web authentication is something a bit more deeper. So how to use them? We can say that user should keep and provide it inside the cookies. So we just send him a cookie with the JSON Web Token, and each request will be automatically, browser will automatically add the correct cookie with the JSON Web Token. This is has some drawbacks, has some good points. The good point is that when there is a breach, XSS breach for your web application, and somebody executes some arbitrary code inside the user context, we can provide that cookie is not it cannot be written by JavaScript. It's only on the HTTP request, so attacker cannot get that token. Also, cookies can be used with plain requests that are not made by made asynchronously by JavaScript. So simple loading of the image or whole page will also contain the cookie. For headers and for Drawbacks, we need to have some CSRF protection because cookies are sent with every request to our website, also with requests that are from other sites, unless that they are created from JavaScript, but any images and any form data, etc., will be sent with those cookies. So somebody can create malicious form that will execute something in our site on behalf of that user. For headers, there is no need for CSRF protection because we control when the headers are sent or not. But this JSON Web Token has to be accessible by JavaScript, has to be visible, so any breach, then the Web Token is leaked and somebody can use it. And it can be only used in XRL calls, so in the calls created from JavaScript. So first we have to load the page for the user that is generic, doesn't require authentication, and then API calls will authenticate the user in our application. I recommend using headers because even if we have breach with cookies, that breach already allows anyone to create requests from the user web browser, so there is not much benefit of keeping this token away from attacker in that case. And the headers have like built-in authentication data, CSRF protection. There is no need to create additional protection for that. So what to use them for? Identifying user. So we can set that this user is, for example, John Doe inside the web token, and our web service can trust that data. We can store permissions that a user has. So if we have some multi-components website, that one, for example, is responsible for authentication, other one for something else. This other one can fetch the permissions for the user directly from the JSON Web Token. So there is no lookup to the database for that. The same for the groups, for any other credentials, etc. What not to use them for? Any state storage. It is just not the place to store like the step of the multi-step form or something like this, because it can be modified by a lot of It can be modified by a lot of different sessions of the user, the same token, and it will just lose some data in that case. So any state storage or any changing that data shouldn't be kept here. Those data should be kept inside the cookies directly from the web browser or any storage inside the web browser. And it should be held by web browser, so there is no request latency because JSON Web Tokens has to be signed by your servers. So user browser cannot change the content on JSON Web Token, and that latency when waiting for the new token can cause some data loss. Those things you should keep either directly in user's browser or in your database on your site completely. So why JSON Web Tokens are good? Because we don't have to fetch from that database on each request permissions of users, who is this user, his session, etc., etc. We have everything kept inside JSON Web Token, and as it is assigned, we can trust it. It's actually easy to use. There are plenty of libraries for every language that you can write web applications in to leverage the JSON Web Tokens, and it's supported everywhere. Like in every language you can use it, etc. Why they are not good? They are a bit harder to understand. Look at this example. You cannot see anything as at first sight on this example. So, yeah, bit hard to read, bit hard to understand what they are doing, etc. You need some cryptography, so this is like computer power to verify them, to sign them, etc. They are not secure by default. Unfortunately, there are some holes that you have to patch by yourself. I will provide the examples later, and it is hard to invalidate. If, for example, you want to force logout of the user, you should have to either remove it from his browser, and you cannot trust that because he can, for example, block it, etc. If, for example, his account was compromised and you want to log out all of his sessions, or you can store that JSON Web Token so you know that this is valid, and you can like checkmark that this is not valid, but this will introduce the database check every time so that JSON Web Tokens by itself is pointless. But there are some tricks to do it the right way. For example, you can create like revocation list. So yes, specify some token, some like random part, but not whole JSON Web Token. Set it inside the token. Put it somewhere safe so you can look up every single one of these tokens that user have. And instead of doing database check to see if it's still valid, you should create a revocation list. So all the list of tokens that were invalidated, because this is just quicker. This list is very short, and lookup for that is very, very quick. Other thing is just to set the very short expiration time for the tokens, because they have a field for expiration time, and you should really, really use it. So, common mistakes and security problems. First of that, let's try to hack some signatures. So we have the JSON Web Token. We can encode the data. We see that there is admin flag, so yeah, this token works. Let's try to check the admin flag to true. Unfortunately, we don't have access to that application responses with unauthorized, so it knows because the signature is wrong. But what? Let's look at header. What do we have here? We have here algorithm and type. What if we changed algorithm to none? Any guesses? Of course, the data of the header changes, and yes, it works. And this is actually, if you look at my previous slide, the none is the valid signature algorithm for the JSON Web Token. It is in specification. You can look it up, and it is actually recommended, like not recommended, mandatory for each application that implements JSON Web Tokens to support that non-algorithm. You can not respect that, but you have to check if somebody didn't change that algorithm. But you should have code to support it inside your code. So yes. None just means that you don't check valid the signature at all. The question was if none means just basic 64 encoded. This none means that your applications should just ignore everything that is in the last part, so whole part in blue, and just treat it as the whole token as validated, etc. So, yes, you cannot break security if there is non-security, of course. Always check signature type. If you're writing the application with JSON Web Token, create some whitelist for the signature types, and always check if the right one is used, especially if it is not known. Okay. One.NET framework did something bad in implementing the JSON Web Tokens. So, this is again the same JSON Web Token. We again check what the admin flag, and we try. Unfortunately, it didn't succeed. Oh, wait, what is that? Expected signature? Okay, I can use it. Thanks. Okay, so watch out. This was only available in signature, in debug mode, this signature, but as you know, debug mode often happens on production, so don't use that. Please check what is returned in debug mode. This already has been patched. I won't mention which .NET framework was that. And okay, let's see. We can use asymmetric signatures. So there is different key for creating JSON Web Token and different one for verification of JSON Web Token. Then we can have multiple services, and only one can create the JSON Web Token, other one can only verify it. So public key is known by frontend. We are assuming that private key is not known by frontend, only by application inside, but public key is known, so it can verify signature, so it can crash on the user side if the signature is wrong. Convenient, there is no request needed, etc. for signature verification. Frontend can do it by himself and just say to user that something is wrong, and he has to log in again. So there is the same data, but encoded with different key, this time asymmetric, so header is different and signature is different. We change the admin flag to true, the data changes, and of course, it's invalid signature. But wait, we have public key. What we can do with public keys? Well, computing private key from the public key is not easy, but all we know is that server side knows that public key. So, what if we try to create the HAMAC SHA-256 signature using this public key as the private, as our secret. Image H256 is a symmetric algorithm. It's not asymmetric. So there is the new signature, and now let's change the signature, the algorithm used to the symmetric one. Who knows what will happen now? Well, yes, we are admins. Why? Because most of the time, many JWT libraries will take just 3 things when validating token. 2, actually. Your token data and the key. It doesn't distinguish between asymmetric and symmetric key at this point. So if you put some key and it looks it should be symmetric encoding, it will just use the algorithm that is provided in header to verify that token. So yeah, always check signature methods again, and choose your keys accordingly. So if you want to support 2 different algorithms, one symmetric and one asymmetric, check that. Always check which one to use. So don't on top of that, don't reinvent the wheel. If you are trying to use JSON Web Tokens, somebody probably created a library for that, and it is well used, and you should use this one because it's tested by community. It probably doesn't have patches, doesn't have bugs, and if it has any bugs, they will be quickly discovered and quickly patched. Don't reinvent the wheel. This is the cryptography. You shouldn't create cryptography on your own, even if you are like top world expert in that. Use short-lived tokens, always. Peak time, for example, 60 seconds, and after 60 seconds, use app in user's browser should fetch the new token. You don't have to log out the user. You can create like another token just for renewing the this short-lived one. This you can you should really store in the database. This one for renewing, so it can be it can be just removed from the user, so made no longer valid if needed. Never use secrets between 2 separate websites. That's very common case when somebody creates an app for multiple clients. This app works the same way for all the clients. So why bother checking if the secret is not the same? What wrong will happen? No. Owner of one application can bypass security for the another application using that. Ensure that only one party is creating JWTs. So if you're creating like multiple services, pick one that will be only one responsible for creating new JSON Web Tokens, for logging user, etc., etc. And this should be only one that is creating JWTs. No other part of your application should be allowed to do that. You can even ensure that it's in place by implementing asymmetric cryptography, so any other part of your application is not capable of creating a new valid JSON Web Tokens, and always use strong keys. Especially for symmetric image SHA-256 algorithm, use long, strong, randomly generated keys. It's not like password that you have to remember. It's kept safe in your application. Generate like fucking big one to your application, because attackers can just log into your app, download some valid JWTs with the signature, with the data that is signed by this key, and slowly work out your secret key. This you wouldn't know even if somebody is doing that, and for not strong keys, it can happen very quickly, and you wouldn't even notice when your application was breached and somebody logged in, did something messy things. So, as we are on Pykonik, let's see some JWT in action in Python. There's PyJWT library that just is for JWT creation. You just set it up. You can download it from PyPI. You just set it up by importing it, setting a key, algorithm for that key. Yes, this library actually verifies that the algorithm for the decoding is one of provided here. So if you provide the algorithm here, and this is only one that you are trusting, this library will handle it for that. For payload, you can, of course, create everything. It will create the signature and the header for you. You don't have to worry about it. Encodes just fine. It's great. So, if you try to like mess with the signature, it will throw an exception for you. So, you can be pretty sure that verification failed, unless you are treating the exceptions like Pokemons and catching them all. So you can like miss it if you catch it, and that just happens. So asymmetric signatures also are supported. Just create some private and public key. When encoding, you just provide the private key and the algorithm that is should be used. These have to be always on the encoding. And for decoding, also you are providing just public key, and you can see actually that this key for asymmetric and this public key for asymmetric is on the same argument provided to the request. So if you are using asymmetric signatures, always specify algorithm. So you can also add some additional things to the header if you want to be non-compliant with anything that is in the RFC. You can create some random header with some random data. Whatever you want can be provided in header. JWT library will just support that. And for expired tokens, of course, you can catch that signature has been expired, or you can create some. So for this expiration data, and for like waiting some time and checking, this line with the code, you can set the leeway to the token right here. So it will mean that JWT decode will accept expired signature if it's in some range of expiration. So, for example, if it's like 40 seconds and it's set to 30 seconds, it won't accept, but 32, it's fine with that. So you can set that leeway, that small window, you know, for example, for renewing the tokens, or just take into consideration some network latency. It's there. You can set off the expiration with the options. You can set verify expiration false. Then it doesn't verify expiration. If you want for some crazy reason, don't verify that, or like don't verify if you are allowing user to renew the JSON Web Tokens. You can do it that way. And thanks. That's all from me. So, any questions? Yes.
Do you have any requirements for the payload, like non-binary data, for example, or can
Actually, if you want, you probably can throw, let's go to the, yes, just repeating the questions, if there is any requirement for the payload, if it can be any binary data. Some libraries, I think, will just accept the binary data, just encoded with base64. Normally, the header and the payload, if you decode that base64, it decodes to the JSONs, hence the name JSON Web Token. But I think some libraries can be fed by the binary data inside, instead of this JSON, but that might not be the case. I don't know if the PyJW that I showed will accept that. So just to be sure, encode binary data as base64 and put it inside the JSON as one of the fields. Anything else? Yes.
The PyJW library, do you need to specify the algorithm? Like, is it required, or you can omit it?
Up to, you mean this for decoding. Yeah. Up to some version it wasn't required, before it wasn't even available to specify that. From particular version, I think that it is required. But don't quote me on that. I don't know if it's 100% true. Okay, anything else? Okay. Yes. What about the non-algorithm was the question, but anything? Yes. So question was about the non-algorithm. If you set it in the algorithms for the decode side, how it will behave? It will just comply with the non. So if you set algorithms to none here, it just will reject, accept any JSON Web Token that has the algorithm none inside the header. Of course, this algorithm is checked inside the header. So if you specify none there, you have to provide none inside the header of the JSON Web Token. Properly signed JSON Web Tokens won't be then accepted. And these algorithms can be list. It don't have to be only the string. You can specify it either by list or by string. So you have the flexibility there if you are using multiple algorithms. But if you are using like one that is symmetric and one that is asymmetric, don't rely only on that. First, like you can decode the JSON Web Token with flag that will skip verification of algorithm. There is another flag for that. Check what algorithm is inside the header. Fetch proper key, because for symmetric and asymmetric they should be different, of course. And then do actual verification with this flag unchecked. So you are verifying with the correct key for the correct algorithm.
For the convenience, JWT sometimes read JOT.
Okay, so interesting fact, I repeat for the stream, that JWT is sometimes read as JOT. JOT, yeah. Yeah, so let's meet JOT then. Anything else?